Hey everybody, this is chapter 3, section 4. Title is Solving Multi-Step Inequalities, starts on page 186. Again, just like sections 2 and 3, the steps in this chapter are very similar to the steps that were in chapter 2. In fact, the steps for solving multi-step inequalities are the same as the steps that we use to solve multi-step equations. And I wrote them down again. First, look for the distributive property. See if there's any like terms that you can combine. Look for variables on both sides and try to get rid of one of them. Then after that, what's the variable? What's being done to it? Which one of those things do I deal with first? What's the inverse of that? Do that to both sides and simplify. And then since in step 6 there were two different things being done with my variable, I have to go back and do the other one. So I repeat from steps 4 to 9 again. And then again from last section, don't forget to switch the inequality symbol if you multiply or divide both sides by a negative number. Okay? We've got a handful of examples that go along. What are the solutions of negative 6a minus 7 less than or equal to 17? Okay, my variable's a. There's no distributive property. There's no like terms. There's no variables on both sides. So a is my variable. It's being subtracted by 7 and multiplied by negative 6. The one I want to get rid of first is the one that's farthest away from the variable, which is the minus 7. So I'm going to add 7 to both sides. Inverses cancel. Negative 6a less than or equal, 17 plus 7 is 24. A is my variable. It's being multiplied by negative 6, so I need to divide by negative 6. Inverses cancel. And remember, I divided both sides by a negative number, so I need to switch my inequality. A is greater than or equal to negative 4. This problem doesn't say graph it, so you don't have to. We're going to skip example 2. We're going to come back to that at the end of the lesson. So example 3, what are the solutions of this problem? The first thing you notice that there is distributive property. So I'm going to have to distribute first. Negative 2 times 4 is negative 8m. Negative 2 times 7 is negative 14. So I use the distributive property. Now, the next thing on my list, like terms. Do I have any like terms? Yep, the 5 and minus 14, those are like terms. So I'm going to combine those. 5 minus 14 is negative 9. Okay, next on my list of things to check, do I have variables on both sides? No, so I can continue. M is my variable. It's being subtracted by 9 and multiplied by negative 8. I need to get rid of the subtract 9 first because it's farther away. The inverse of subtracting 9 is adding 9. Do it to both sides. And I get 24 less than or equal. Those 9s are inverses, so they cancel. Negative 8m. M is my variable. It's being multiplied by negative 8, so I need to divide by negative 8. Both sides. 24 divided by negative 8 is negative 3. These 8s cancel, so I have m left. I divided both sides by a negative number, so I have to switch the inequality sign. Now, if you prefer to have your variable on the left, you can take that answer and switch it around. So this can be your answer, or you can flip it around and get m less than or equal to negative 3. Both of those answers would be correct. Example 4, if you look at this problem, no distributive property, no like terms on the same side of the inequality, but I do have variables on both sides that I don't like. So I need to get rid of one of those. I'm going to get rid of the negative 2b. Again, I'm trying to get rid of the whole thing, not just the negative 2. So I'm going to add 2b to both sides. Inverses cancel. 3b plus 2b is 5b. b is my variable. It's being multiplied by 5 and added by 12. I need to get rid of the 12 first, so I'm going to subtract 12 on both sides. Those cancel. 5b is greater than 15. Remember, even though I subtracted by 12 on both sides, that's a negative number, but I didn't multiply or divide by a negative number. So the inequality symbol stays there. Okay? B is my variable. It's being multiplied by 5, so I need to divide by 5. And I get B is greater than 3. In Chapter 2, we had special answers for problems where the variables all canceled out. If the solution was true, we called it an identity. If the solution was false, we called it no solution. There are special cases for Chapter 3 also. If the variables all cancel and the inequality is true, the answer is all real numbers now. It's not identity anymore. If the variables all cancel and the inequality is false, the answer to that is still no solution. Example 5a, what are the solutions of this inequality? I have variables on both sides. I don't like that, so I need to get rid of one of them. They both have the same number, so I can just pick one. Subtract 5n, do it to both sides. The variables cancel, and I get 9 is less than or equal to negative 1. Is 9 less than negative 1? No. Is 9 equal to negative 1? No. So that is false, which means no solution. In this problem, I don't have distributive property. I do have like terms. On the right-hand side, I have 7x minus x, which gives me 6x. Okay, I have variables on both sides. I don't like that. I need to get rid of one of them. So I'm going to subtract 6x. Do that to both sides. Those are inverses, so they cancel. Those are inverses, so they cancel. And I get 8 is greater than or equal to 2. Is 8 greater than 2? Yes, it is. That's true. And again, it's not identity anymore. It's all real numbers. That's my special answer for if I get something that's true when all of the variables cancel. Okay, go back to example 2. We skipped this one. The perimeter of a rectangle is at most 24 centimeters. So, there's a rectangle. Two opposite sides are each 4 centimeters long. So opposites would be like this one would be 4 and this one would be 4. Okay? What are the possible lengths of the other two sides? Now, if it's a rectangle, these two sides are going to be the same. Perimeter is when I add up the distance all the way around it. So I've got 4 plus x plus 4 plus x. And that total needs to be at most 24. So at most, can it be equal to 24? Yes. Can it be bigger than 24? No. Can it be less than 24? Yes. So I use less than 24. Now I've got like terms I can combine. 4 plus 4 is 8. X plus x is 2x. Now I can solve my multi-step inequality. X is my variable. It's being multiplied by 2 and added by 8. The 8 is farther away, so I need to get rid of it first. So instead of adding 8, I need to subtract 8. Those cancel, and I get 2x is less than or equal to 16. Divide both sides by 2, and I get x is less than or equal to 8. Don't forget this is a word problem. You need a label. It's dealing with centimeters in this problem. So my unit is 8 centimeters. X has to be less than or equal to 8 centimeters. Practice problems in this section, page 190, numbers 9 through 33 odd.